Okay, let's start. We will start with this question over here. At what nominal rate of interest compounded semi-annually will money grow from $23,000 to $30,670.16 in 8 years? Round the value of IY to 2 decimal places. So we want the nominal rate of interest compounded semi-annually. We're trying to compute the nominal rate of interest, which would be IY, and it's compounded semi-annually, so it means that PY is 2, and so will CY. All right, now the present value is this 23,000 right here. We can copy and paste it into there. And the future value is this amount up there, which we can paste in there to avoid any errors. And 0 is the payment, it's compound interest. Okay, so let's use the calculator now. Second IY, we enter the value for PY, it's 2, and CY is also 2, so 2, enter. And that value is recorded for CY. We will come out by clicking on second, CPT. Now we are given the number of years, it's 8 years, so we go 8, and we go second, NN, so 8 times 2, the 2 coming from right here or here, 8 times 2 gives us 16. Now we're computing the IY, so we pass over that, and we go to the present value, which is 23,000. So we go 23000, and that's the present value. 0 for the payment, so 0 payment. The future value is 30,000, 30670.16. And that's the future value. And now we will compute IY. All right. And we get an error of 5. Why is that so? Well, let's recall the present value. You see that is positive. We recall the future value. We will have to make this negative y, because that is how the calculator operates. Remember previously when we just started and we computed this future value right here, it ended up with a negative sign. So we have to put one of them in as positive and the other as negative. Doesn't matter which one, but they have to be opposite signs. So now we will compute the IY, and we get an answer, if we round to 2 decimal places, 3.63. All right, and that we're rounding to 2 decimal places. So a 9 shows up after the 2, so therefore that should be the answer. And there it is. It is correct. So that is what you must be careful about. If you put the present value in as positive, then the future value must go in as negative. On the contrary, meaning the opposite, if we put the future value in as positive, then we will have to change the present value to negative, and it will also give us a correct result. So what we should learn is that if you see an error of 5, chances are that is what has occurred, meaning the present value and future value have the same sign, positive or negative. Okay, the next question. An amount of $10,000, that is present value, okay, that is deposited into an account today. It is expected to increase to a maturity value of $11,300.36, which would be the future value. Okay, and we will put that in as negative or indicated as negative so that we will not be errant in entering the value without the correct sign. All right, now payment is 0. What else do we know from this? It's for 5 years, 5 years from now. And what is the nominal interest rate compounded semi-annually? So semi-annually means CY will be 2, and so will CY. And the IY value is what we would like to compute. Remember, the computation is last after the other information has been entered. Now, this value for n would be 5 times 2. The 2 coming from over here, one of these, they're the same value. And the 5 coming from the 5 years up there. So 5 times 2, so we should get 10. Okay, let's go to the calculator. So second IY, and CY is already 2, and CY is 2. We don't really need to enter them if we do not do so. Like I said, we can exit the menu by clicking on clear twice. We'll just get rid of that number. So 5 second n produces the 10, which was the expected value for n. So it is indeed 10. Now, IY we're computing, so we'll have to input all these numbers, these numerical values, and the last step is to compute IY. Okay, so $10,000 for the present value, 10000. That's the present value. Payment is 0, 0 for the payment. And the future value is $11,300, 11300.36. And let's make that negative because we had put in the present value as positive. Now we can check, we can recall the present value and we see that it is indeed positive. So now we can compute the IY value and it looks like it will be 2.46 if it's rounded to round the answer to 2 decimal places. So the answer here for IY will indeed be 2.46. And we submit, and there we are. So it is indeed correct. Okay, let's go to the next question. In how many years will $20,000 have an accumulated value of $23,910.99 if interest is 2.3% compounded semi-annually? Okay, so this $20,000 is the present value, correct? So let's copy it and let's paste it into here. And the accumulated value, so that is indeed the future value, $23,910.97. So there we are. Okay. Interest is 2.3% compounded semi-annually. So we take the 2.3% and we put it in there. Compounded semi-annually, so we have 2 for PY and 2 for CY. All right, the payment is indeed 0, and now we have to compute the years. Years really do indeed, or does, the years correspond to that computing the value for n. Remember, n is the number of years times CY. If we open up the Word document, we can put that in there. That n is equal to the number of years times PY or CY. It doesn't matter which one you use, correct? Let's use the PY so we can get it correct. So the number of years would be equal to n, and we have to divide by, yes, we have to divide by PY. Okay? So there we are. All right, so that is what we have to do, and we will do that now. So let's go back to the question, go to the calculator. We'll input our values, and we have second IY, so PY is 2 and CY is also 2. Okay, let's put 2.3 for the interest rate, so 2.3, that's IY. And the present value is 20,000, 20000. That's the present value. 0 for the payment, 0 for the payment, and then this is the future value, $23,910.97. So that is the future value. Okay, we will have to, it's best if we do indeed make it negative. and put it in there. That's the future value. That's the present value. Now we will compute n. Right, so n turns out to be 15.62. Now, if we look at if we bring this up here, and we can manage to grab that over there. Now it's kind of small, but we can do the computation, I think. So the number of years is equal to n divided by the, okay, let's maybe hop over there. All right, there we are. So number of years is equal to, and the value of n is what? Well, we had it on our calculator there, 15.62, correct? Okay, so let's do that. We will put 15.62. All right, I think we're having a little bit of a problem, but py is indeed 2, so we know the value for py. All right, so maybe we should go back like that, and that might help us to get organized into the right position. So 15.62 and divided by 2, and that will give us a result by using the calculator. So 15.62, let's divide that by 2 right there, and we get an answer of 7.81. So this number should be 7.81. Now we can save ourselves some work maybe and just copy it here and then go back into here and just paste it here. Now we know 2 decimal places, so we are all right. That should be correct. And we submit and it is correct. All right, now maybe you might be wondering what happens if we had made the future value positive also. There it is, it's positive, present value is positive. Now let's go and compute n. And we do get an error 5. So if you see an error 5, you know what has happened. You can recall one of those 2 values, and one has to be positive, one has to be negative, and now we compute n, and we are back to the original value. And then we divide by the py value of 2, and there we are, 7.81 is correct. Okay, let's go to the next question now. How long will it take? It's the same kind of a question, but in this time it's years and months. For $200 to double in value if it earns interest at 3.97% compounded quarterly. All right, now what is double? Double means that it's twice this amount. So if this is the present value, which we will insert in here, and the future value would be what? 200 times 2. And that should give us 400, correct? Yes. If you go 200 times 2, and we get 400. Okay, so this number should be 400. And we come over here and we delete there, and we are doing very well. Now, what else do we need? Well, we need the interest rate. It's 3.97, so we can copy that and we can paste it into here. All right, now it's compounded quarterly, so quarterly means py equals cy would be equal to 4. Payment is 0, and so we have to compute n. That's the first thing we do. All right, now this is some explanation about what will happen after we do the computation for n. So let's go ahead now and start. So we start with the py value, py cy, it is 4. Maybe make it a little bit larger and we can see it a bit better. All right, so there we are. So 4, enter, there we are, and that is the same for cy. So we come out of there and we enter the interest rate, which is 3.97, 3.97 interest. Now we passed over the n because we are computing that number. Okay, now we need the value for present value. It's 200, so we go 200, and that is the present value. 0 for the payment. And the future value is 400, so 400 future value. Okay, So now we compute n, or before we do that, I think we should probably make this negative and then insert the future value. All right, so maybe for good, for consistent numerical values or the sign indicator, we should use a negative for the future value and positive. So that the future value is negative. Let's recall the present value, it's positive. So now we can compute n and not be in danger of getting a wrong result. Now there's the value for n, but we would like to get the what? We like to get it in years and months, all right? Now from before, you know that let's go back in there, and maybe we can move this over a little bit here and keep the calculator. So we know what n is about. N is equal to the number of years times py, right? So in this case, right, we have, well, we have that py is equal to 4, correct? If we go back to the previous one, there we go, py equals py is equal to 4. All right, so now we come back here and we can do the number of years would be equal to what? Well, n is 70.1845100, and we divide by 4. Okay, now it's right up on the display on the calculator, so we divide that by 4, and we get the number of years. So that is equal to 17.5461275 years. All right? If you wish, you could put a separator so you know, and maybe after all of that, we should just bring this down here. All right? So you have the number of years. So why don't we do something like this? Put it as 17, all right? And then put 0.5461275. All right? So we have 17 years. Let's put in the years in here. That's the years, and this is the part of a year. Okay, so what happens is we have a whole number and a decimal part. So we can put in the number of years as 17 right there. But the decimal part is what we have to convert to months. So 0.5461275 of a year is equal to what? 0.5461275 times 12 months. Okay? Months, M-O-N-T-H-S, which is equal to what? So we subtract 17 from this. That's the whole number part. We're left with the decimal part, and that we multiply by 12. And that will give us a number of months. So any part of a month, we have to round up. So this, if we were, say we were keeping 2 decimals, let's say 5, and then we put in some dots, those are months. All right? So that would be now equal to 7 months. And then we can say rounded up. All right? Maybe use uppercase for that. All right? So let's bring this down here maybe, and then we can put it like that, or we should probably brought the equal sign with it, and then come up like that, correct? Yes, we put this 6.55 and keep going, 35300, and then we round that up to 7 months. So this would indeed be the answer for the number of months. So 17 years, and then we will put in 7 for the number of months. All right. Now this is what all of this is here, this description is about. Round the month to the next higher month. So even if it's 7.1, it becomes 8. Do not enter a value of 12 months. Fortunately, we didn't come up with that. It must be converted to another year. So you do not put 2 years, 12 months. You must put 3 years, and you must put 0 months. All right, years must be an integer. That is very true. You can only have a whole number of years. But if years is an exact integer, such as 17 years, 0 months, is 0 must be entered for month. All answer boxes must have an entry. In this case, we had no need to do any. When we rounded it up, it still kept 7 months. So this answer should be correct, and it is. All right, so you just have to be careful and read the instructions here. All right, I know it's a lot there, but it's hopefully it'll demystify any doubts, take out the mystery of any of what you need to insert for an answer. Okay, now here we are. This is another question. In this case, now what do we ask for? Well, okay, Olivia invested $4,580 into an account. So let's copy that and paste it into the present value. That earned 7.7%, so that is the interest rate. We can put that in here. And then it's compounded semi-annually. Okay, so PY is 2 and so is CY. How long will it take in years and days to accumulate to $7,800? Now that would also that will be the future value. 1 year is 365 days. All right, same rules like what we did before about the rounding of the number of days. Now payment is 0. Let's go ahead and do the calculation. We're computing N. All right, so second IY and the PY value is 2 in this case, so 2, and we enter it, and that is also for CY. Now we are computing N, so we pass over that, and then we go 7.7 for IY. Okay, now the present value is 4580, 4580. Okay, your payment is 0, 0 for the payment, and the future value is 7,800. Okay, that is the future value. So we now go, but we should make it negative. That is right. Why? Because the present value is positive. So now let's compute N, and that is the value for N. Now, you know how to do it. We have to divide by PY, correct? That is how we get the number of years. So let's do it directly on the calculator. So we're dividing now by PY, divide by 2. And that gives us the number of years. Now, the whole number part would be the number of years. So we have 7. And what we do, this is the 7.0468751 years. So if we subtract the 7, we'll get a decimal portion of a year. Now, we want to convert years to days. Days is the answer. And here we are given that 1 year is 365 days. So we'll have to take this decimal part of a year and multiply by 365. And that gives us 17.1. So this must be rounded up. So it has to be 18 days. Okay, and that is how it works. So let's submit and see if it's correct, and it is correct. So that is how it's done. And hopefully you can follow and you can do likewise on the quiz and have good success with your quizzes. And I hope you are doing them. And the best way is to try the quizzes. You're allowed 5 attempts, like it says at the very beginning, the instructions. You have 5 versions of each question, 5 attempts on each version. The best score will be kept. So please start. There's no reason why you shouldn't. Quizzes do not have to be completed in one session. Your work will be saved and you can come back and finish later. But be sure to finish before the deadline and be sure that you do not click on submit. If you click on submit, then it's submitted. That is what it means. You have terminated the quiz. And then you might have to ask for a reset if you wish to do it again, but it cannot be retrieved to continue. Okay, so please note that. That is it for today. I will stop the recording, and that should be the end of it. All right, record, stop recording, and